So in this section, we're going to talk about matrices. What is a matrix, right? Well, a matrix is something that we use in mathematics to organize numbers or values, and it helps solve complex mathematical ideas. Businesses will use matrices as far as setting up cost models. So if you have like a piece of software where you can type in how many of different products and then it spits out a total cost at the end, it's basically running that through matrices. So it's using that mathematics, this mathematics we're going to cover to handle that. We're not going to get completely into all the ins and outs of matrices, but we're going to get into some of the basics, and then we're going to see some applications with the idea of systems of equations. Okay, mathematically, it's rectangular, a setup of rows by columns. Okay, so here's some examples. So, definitely, what is a matrix? Not this. This is not what I'm talking about, okay? When we're talking about a matrix, or we're talking about plural matrices, I'm talking about math here, okay? So here's an example of a 2 by 2, okay? Rows by columns. It has 2 rows and 2 columns. The rows go left and right. The columns, like the columns of Greece, go up and down, okay? And I just kind of came up with this example. Let's say you had a snack shop, and you had $2 popcorn, $1 candy, $3 soda, and free tap water. And you're like, well, I want to set up basically a mathematical equation that shows all the different possible costs. Well, you could organize it. So what I did is I put the food on the left, $2 popcorn, $1 candy, and on the right I put the drinks, $3 soda, and free tap water. And this would be a way that I could set up this matrix, and then I could have another matrix that says how many of each did they buy, plug those two together, and then I get a total cost. That's what those machines are basically doing, is that this mathematics. Once again, we're not getting into that. I'm just trying to give you an example. What if instead of a 2 by 2, I had a 3 by 2? Now, instead of 2 rows, I have 3 rows by 2 columns still. Building on that word question I talked about, now that snack shop is upgraded. They said, man, we're making so much money. Let's add $4 hot dogs and a $6 beer. Okay. Oh, buddy. So that just adds another food item and another drink item, and you could then again expand that. You could have a matrix that, and I'm not, the story question ends here, but you could have 1 by 3, that is 1 row by 3 columns, or you could have that same set of numbers listed as a 3 by 1, 3 rows by 1 column. So this is just to give you an example of how different ways that you could set up matrices. What can we do with them? Well, the first thing we're going to do is we're going to add, subtract, and multiply them. Let me show you what I mean. So here's a matrix. I have E was 7, 4, negative 1, or 1, negative 3, 5, 2. And we said, well, if that's E, what is 2E? Well, it would just be twice as much. So literally, all we would do is we would take this 2, and it would distribute across each of these terms. So instead of 7, it'd be 7 times 2, 4 times 2, 1 times 2, negative 3 times 2, 5 times 2, 2 times 2, and that would be it. I need to shrink my little matrix there. And so, distributing that 2, we would just end up with 14, 8, 2, negative 3, 5, no, 10. Try again. Where are we at? Negative 6, 10, and 4. And that would be 2E. Here's B. It's a bigger matrix. It's 3 by 3, 3 rows by 3 columns. What would 5B be? Well, each of those numbers would now get multiplied by the 5. So 4 times 5 would be 20. 0 times 5 would be 0. Negative 7 times 5 would be negative 35. Negative 2 times 5 would be negative 10. 1 times 5 would be 5. Negative 3 times 5 would be negative 15. 2 times 5 would be 10. 7 times 5 would be 35. And negative 4 times 5 would be negative 20. So we can multiply a matrix. That's just called scalar multiplication. When would I use this? Well, let's go back to if I'm running a store and these are a bunch of different products. Let's say we are running a sale, so I'm going to mark everything down. Everything's 20% off. Well, then I could multiply all of the costs by a percentage, and it would lower all the costs of the items. Here we marked up the cost 5 times. So maybe I'm running a business and everything I buy, I mark it up 500%. Well, then I would multiply each of those costs times 5. So just some different applications here. The next thing they're going to have us do is adding and subtracting them. So here I have a matrix A and a matrix B, and I pull this straight out of the examples on Alex. So if I did A minus B, then it's going to be A, which is 6, 5, 3, 4, negative 7, and 2, minus 4, 7, 0, 2, negative 2, and 6. Okay? So what I'm going to do before I just subtract these, put that up there, okay, is I'm going to distribute the negative. When you subtract a matrix, everything in there changes signs. So this A minus B is basically the same thing as A plus a negative B. So I have my A, didn't change, plus, and then minus B, all of those become opposite. And last, once I have distributed the negative, when we add a matrix, we just add up each piece with the matching piece on the rectangle. So this would be negative 6 plus 4 is 2. Then we would follow with the top right. And I'm going to run out of colors here, but that's okay. 5 plus negative 2 would be 3. I could do 3 plus negative 7 is negative 4. 4 plus 2 is now 6. Negative 7 plus 0 is negative 7. And 2 plus negative 6 is negative 4. So they just match up. They line up, and you add the pieces that match up. Here's an easier one if I just wanted to do A plus B. This gives me a little extra space to work this one out. That would be 6, 5, 3, 4, negative 7, and 2, plus, get rid of that, 4, 7, 0, 2, negative 2, and 6. So the difference on this one is that I don't have to distribute anything. I can just line them up. So the top left, I'm going to match the 6 plus 4. The top right, I'm going to match the 5 plus 2. Next one, I'm going to match the 3 with the 7, the 4 plus negative 2, the negative 7 plus 0, and the 2 plus 6. And we combine them to give us 10, 7, 10, 2, negative 7, and 8. And then my last example here, just for fun and giggles, A minus A. You're like, well, that's just 0. Well, sort of. Take the A, minus A, right, becomes A plus, and then distribute the negative. So negative 6, negative 5, negative 3, negative 4, positive 7, and negative 2, right? And when I add those, a little more space here. I'm sure you can all do that too, just cheat a little bit. Except for that one bugger line there. And a couple other things didn't move. So where was it? A minus A. So A plus negative. All right, so what does that give us? Well, negative 6 plus 6 is 0. 5 plus negative 5 is 0. 3 minus 3 is 0. 0, 0. Not that the answer is 0, but it's a matrix that is still 3 by 2, all filled with zeros. All right, so we can multiply, we can add. Next, we're going to do both, multiply and add. So 2A plus 4C. Okay, so I know that A is negative 3, 0, 6, 5. So 2A would be all of those times 2. Negative 6, 0, 12, negative 10. So you're going to take that 2 and you're going to distribute it in across all of the terms. Minus 4C, I can put minus and then distribute the 4, but it would be easier just to distribute the negative with the 4 across all of these terms, okay? So negative 5 times negative 4, so I'll put plus. Distributing the negative 4 times negative 5 would be positive 20. A 0 here, negative 24, and positive 4. So I now have multiplied, multiplied. We can now add what's left. Negative 6 plus 20 is 14. 0 plus 0, it's not very exciting. 12 minus 24. And negative 10 plus 4 is negative 6. A minus 3b. A is negative 3, 0, 6, and negative 5. I'm going to distribute a negative 3 to the b. So what that does is that gives us negative 9, negative 3, 0, positive 15, negative 21, and negative 6. So how do I add them if they don't match up? Right? I need to match top left with top left, top right, top right. There's a bunch of pieces missing. This one has extra pieces, right? This does not combine. They must be the same size for them to combine. They don't really get into that in the homework, but I just wanted to make sure we discussed it. This does not work, okay? If I try to add a 2 by 2 with a 3 by 2, the calculator or the computer would freak out, okay? What if I did C minus 2A? Okay, so C is negative 5, 0, 6, negative 1. I think. Let me just make sure I did that right. And then I put minus 2A. So A is here. Minus 2A would be positive 6, negative 12, 0, positive 10. Okay? So let's bring that down. So they match. Negative 5 plus 6 is 1, 0, negative 6, and 9. And that's as crazy as we're going to get with as far as operating matrices with matrices. Now we're going to get into what you can do with matrices and how they help us with these systems of equations, because all of this is in the systems of equations section. Well, let me show you what you can do. First things first. Oh, dang it. You can do what is called the determinant, okay? The determinant, as far as applications, we're going to use it for solving. Another application, Chinese used determinants thousands of years ago to find the area of irregular shapes. So if you had a triangle and you could map out several points to it, you could do the determinant of the points and it would give you the area of the triangle. So kind of a fun fact. This is not a new thing. This math has been around for, probably about 3,000 or 4,000 years. But one thing we can do with it, so if I have matrix A, B, C, D, okay, we'll call that matrix A. Then A, with these straight lines, okay, is basically saying do the determinant of A. The determinant is basically going down minus going up. So down would be AD, minus going up would be CB. That's it. So it's kind of a weird thing, but we'll show you some neat applications for this in just a second. But let's do it first. So here's A. What would the determinant of A be? Well, down minus up. So down would be 3 times negative 2 minus up 1 times 4. That would give us negative 6 minus 4. So the determinant of this would be 10. I can do the same thing with B. Down minus up if I wanted the determinant. So down would be 4 times negative 2 minus up 8 times negative 1. That becomes negative 8 plus 8. This would have a determinant of 0. I can actually do this in the calculator as well. So if you have the calculator, I have. If not, you might have to look it up differently. But to set up a matrix, for me, it's in this little button, and I have all these different shapes. The two we're going to be using mostly is the 2 by 2, and then if I need something bigger, I click here, and I can customize what size I want, but it defaults to 3 by 3. We will be using 3 by 3s, but for now, we are just using 2 by 2s. Okay? But if I want the determinant first, what I do is I go to Menu. We're messing with matrices, so I go to Matrix, and do you see Determinant? Determinant, set up the matrix. So I click that button, I go to the 2 by 2, and what were the numbers in our first example, right? 3, 4, 1, negative 2. 3, 4, 1, negative 2. I'm predicting negative 6 minus 4 or negative 10. If I want to do that again, I could go back through the menu and find it. So matrix, determinant, set up a 2 by 2, and then 4, negative 1, 8, negative 2, 4, negative 1, 8, negative 2, and we got a determinant of 0 like we predicted. Okay, so yeah, you should be able to do these by hand. The arithmetic isn't hard. Really, we should also be able to do the determinant of 3 by 3s by hand, but I'm not going to make you do that in this class. You can have technology to do that. So going on, we can use Cramer's rule. Cramer's rule says if I find the determinant of a 2 by 2 matrix and I replace the x with the, what are they called? With the constants over the determinant of the coefficients, then it gives me x. Like, what the heck are you talking about? Give me a sec, I'll show you. Okay. Same thing, if I replace the y's with the constants and do the determinant of that over the determinant of the coefficients, it will give me y. You're like, so what does that mean? Well, here's a system. What if I asked you to solve this? Hopefully by now your answer would be, I would use combinations. You're like, well, what do you mean? Well, these y's are ready to cancel out. So this would be very easy to use combinations. Add those together. Let me copy this before we go on too far. All right. And the y's would cancel out, leaving me with 3x equals 9, dividing x equals 3. How would I get y? We have to plug in x. That's pretty easy. 3 plus y equals 3. Subtracting it, y equals 0. So we have 3, 0. What I did is I picked a question that I knew would be very easy to do by hand, and then I'm going to show you how to use matrices to solve this, and then we'll do the next one where we are not going to want to do that by hand, and I'm going to show you how matrices will make our lives way easier. Okay? So what you do here is you set up D. D is going to be the matrix, or the determinant of the matrix of the variable, I should put of, I'll put with, the variable coefficients. So coefficients. So take the variables right here, take their coefficients, 2, -1, 1, and 1. That is matrix D. D would be the determinant of that matrix, okay? So if I do the down minus the up, keep in mind I can do this with technology, it's not a problem, but just, I'll do it manually this first time. So going down 2 minus, going up, a -1. Gives us 2 plus 1 is 3. That's D. If I want to solve for x, we have to find dx. What I do for dx is I take the constants right here, and they get replaced for the x, for the 2 and the 1. So I take the same matrix, but I replace that 2 and the 1 with the 6 and the 3. And then I have the other two numbers. Okay, so going down, I get 6. Going up, I get minus -3 is 9. So how do I solve this then? Well, we said x was equal to dx over d. That means x is equal to 9 divided by 3. X is equal to 3. We just got the same answer. That's pretty snazzy. How would I solve for y? Well, I could technically plug that back in, or I could solve for dy. dy, what we're going to do is we're going to take, helpful, we're going to take that 6, 3, and this time we're going to put it in place of the y, in place of the -1 and 1. So we will still have the 2, 1, but in place of the y now, we'll put the 6, 3. So that went in place of the y this time. The down minus up would be 2 times 3 is 6. Minus, going up, 1 minus 6 is 6. 6 minus 6 is 0. And we said y was equal to dy over d, which means y is equal to 0 divided by the same 3 we got up there. Y is equal to 0. We got the same answer. Okay, I can do this in the calculator if you really wanted to. I could take and set up a 2 by 2 matrix with our numbers. And our original numbers were 2, -1, 1, 1. So 2, -1, 1, 1. And that is D, right? If I want dx, I replace the x part with the 6 and the 3. Nine divided by 3. There's our first answer. What if I want to do dy? Well, then I take the original matrix and I replace the y's. I take them and replace them with a 6 and a 3. And 0 divided by 3. There's my y answer. So we can do it pretty quickly with the technology if you'd like. Or manually. This one, I do not want to do manually. See, here's the problem, okay? If I was trying to solve this by hand, I'd have to maybe make the y's the same, which means I'd multiply the bottom one times 7. This would become a 91x. This would become a 56. That does not seem like fun to me. So what might be easier is to set up D. Remember, D is just the matrix with these coefficients. So 5, -7, 13, and that's a 1y, so 1. So the determinant of that would be 5 minus, what is that, 70, 91, minus -91. 5 plus 91 is 96. Somebody right now is going, I don't want to do that by hand. Okay, then do determinant. Here, I'll start over. Menu, matrix, determinant of A, choose 2 by 2. And our numbers were 5, negative 7, 13, and 1. 5, negative 7, 13, and 1. Is that the same answer we got? Yes, it is. Now I would get dx by replacing the 4 and 8 for the x. So there I'm going to put a 4 and an 8. Down minus up would be 4 plus 56, or 60. Well, x is equal to dx over d. X is equal to 60 over 96. X is equal to 10 over 16. Still not done. X is equal to, how about 5 over 8? Keep reducing. Okay? Let's be clear again. Maybe you didn't want to do that by hand. Change the 5 and the 13 to a, what was it, 4 and 8. So change that to a 4. Change that to an 8. Do 60 divided by 96, and we're done. I want to solve for y, I would do dy. This time, we're going to put the 4 and the 8 in place of the y. So we're going to start with 5, 13, and then the 4 and the 8 go in place of the y. Down is 40, minus up is 52, negative 12. Well, y is equal to dy over d. So y is equal to negative 12 over, what was it? D was 96. So negative 1 over 8. If you didn't want to do it that way, you could have taken the original function and replaced the y's with a 4 and an 8. And then divided that by, what was it, by 96. Let the calculator do some heavy lifting. The last section, and I'm just going to kind of show you the power of matrices, is we're going to do it on 3 by 3 systems. Okay, so a 3 by 3 system means I'm now going to set up my coefficient matrix is going to be 3 by 3. And my constants, notice I have 3 of them that we'll replace. But guess what? We are going to solve for x by doing dx over d. We'll be able to solve for y by doing dy over d. And we'll be able to solve for z doing dz over d. Let's start with, what the heck is d? D, remember, is the determinant of the coefficients. 3, 3, negative 2, negative 3, 4, 3, 5, negative 2, and 5. If I wanted to do that by hand, I would have to do 3 downs minus 3 ups. Okay? That is not, to me, the purpose of this. I'm trying to show you how technology can make these way easier to solve. So I'm going to let the calculator do some heavy lifting. Menu, matrix, let's do a determinant. But this time, I'm going to choose a 3 by 3. My numbers, 3, 3, negative 2, negative 3, 4, 3, and 5, negative 2, 5. And if I want the determinant of that matrix, I will hit enter. And we have 196. I don't want to do that by hand. I can, but I don't want to. Our coefficients are this 5, 0, and 4. If I want to do dx, right, those are going in place of the x. That's dx. If I put them in place of the y, that's dy. If I put them in place of the z, that's dz. So I'm going to start by doing dx. Dx is going to be replacing the x's with the 5, 0, and 4. And everything else stays the same. So take this, replace the x's with a 5, a 0, and a 4. So what does this do for me? X is equal to dx over d. So 198 over 196, or 99 over 98. dy, what I do is I take this matrix and I get rid of the y variables, so goodbye, and I replace that with the 5, the 0, and the 4. Very easy to do in the calculator. Take our original matrix and just replace the middle with a 5, a 0, and a 4. 138. So how would I then solve for y? Y is equal to 138 over 196. Or 69 over 98. And last, how would I solve for z? Start by dz. Oops, that's not helpful. Is our original matrix 3, negative 3, 5, 3, 4, negative 2, and replace it with a 5, 0, and 4. We replace the z's this time. So, going back, take our original matrix and replace the z's with a 5, a 0, and a 4. And we get scary looking 14. Which means z is equal to 14 over 196. One over 14. There we go. And that's it. This is way more than you're going to have to do for the homework. Really, the whole point, in the homework, they're going to just have you solve for one of these. You'll need to do z, and then either dx, dy, or dz. But I wanted to make sure we did a few just to get that as comfortable as possible. I do have another example just so we can kind of get this figured out. But we'll do it right now. So here, remember, x is going to be dx over d, y is going to be dy over d, and z is dz over d. I'm not asking you to memorize all of this. You can put some of this on the note card for the test, okay? D is the determinant of our coefficients. 5, negative 2, negative 5, 4, negative 3, negative 5, 4, negative 3, 1. Let's start with that. I'll do it manually again. Matrix, determinant. Oh, I lost it. There it is. Set up the size of a 3 by 3, and we fill in the numbers. 5, negative 2, negative 5. 4, negative 3, negative 5. 4, negative 3, negative 1. d is equal to negative 28. dx, I'm going to replace with a 2, a negative 4, and a 3. So this I'm going to replace with a 2, a negative 4, and a 3. There we go. There's dx. dy, I'm going to replace 2, negative 4, and 3 in place of the y's. So in place of the y's, I'm going to put 2, negative 4, and 3. That is now dy, negative 77. And dz, I'm going to replace the z's at the end here with 2, negative 4, and make sure I do that right, positive 3. Okay. And negative 49. So what's our x? Well, it's negative 91 over negative 28. Both divisible by 7, I think, so 13 over 4. How would I get y? Negative 77 over negative 28, both divisible by 7, so 11 over 4. And how would I get z? Negative 49 over negative 28, or 7/4. That is by far one of the easiest ways of solving this. So mostly what you can be expected to test on, mostly the operations with matrices. I want to make sure you've been introduced to those. That's an important concept that we should see. This application stuff is just showing you one of the applications where we do use matrices in higher level mathematics to solve complex things very quickly. That's the only point of this. I'm not trying to scare you with all these things. I'm trying to show you how we can take matrices with technology and make things that are very complicated way simpler.